So after that last session, it felt appropriate that we might have something a bit more real world for the non-specialists for us. And actually, food is a really interesting sector, I think, because there's a kind of revolution going on. So by 2050, it's predicted that the population of the world is going to rise to about 9.7 from about 7.3 today. And one report suggests that in order to feed that population, agriculture is going to need to kind of increase its productivity by about 70%. And so obviously technology, innovation is going to be absolutely core to that. But we're all consumers of this because we all need to eat. So it's not like an Uber question, but in a way much more fundamental about the world we live in and how we deal with it. On which note, we've got 4 founders of companies at different stages of their evolution and growth. I'm going to introduce each of them, and then fortunately, they're going to give us a little insight into their respective companies. They're all based in California, principally. From my right, further on, Max Brunner from Mavericks, Mavrx in pure Silicon Valley style. Katya Kudashkina from Udio, who's a graduate of the CDL. Lee Redden of Blue River Technology. And Diane Wu from Trace Genomics. So we're going to go in that order in a very alphabetical way. So Max, why don't you kick off and give us a sense of what your company's doing?
Cool. Thanks so much. It's great to be here. So I want to talk about what you're looking at up here on Mavericks is an agriculture analytics company. We build tools for many different parts of the agriculture value chain. And we do that primarily, or at least over the last few years, with imagery as a main data source. So over the last 4 years, we've been collecting terabytes of data on just about every cornfield and many other types of crop fields in the U.S. And a few other countries. We focus primarily on a lot of the broadacre commodity crops like corn, soybeans, wheat, and sugarcane. And we collect a lot of data beyond imagery in order to understand the imagery that we collect. So over the last few years, we've been compiling terabytes of data that includes weather data, yield data, crop rotation histories, soil types, and then satellite history that helps us understand both historic performance, in-season performance, and then use that to really help find a lot of utility in high-resolution imagery. So as we were building those data sets, we were also building a high-resolution imaging network across the U.S. I'm just showing kind of the U.S. as a region where we do work in here. And these, of course, are strategically located to cover just about the entire U.S. production of corn, soybeans, and wheat, which are really our primary focus areas in the U.S. All of our planes, these are manned aircraft, not drones, are equipped with a custom multispectral imaging system that ranges from the visual to the near infrared, where we've selected specific bands of within that spectrum, to understand how healthy crops are, how their nutrient levels are essentially, and then provide analytics and decision support to a lot of our customers. A really good way of sort of understanding how this is put to work in the real world and why this actually matters, and why this on-demand nature of data in agriculture is useful and needed today is kind of best described by one of our customers, for example, in Indiana. Richard Demond has been a farmer in Indiana for over 40 years. He also works for a company called Cova Fertilizer. We probably have not heard of it before. It's a fertilizer company, but it also provides not just fertilizer and chemicals as a product for sale for farmers, but also services. And for the 7 years of the company's existence, they've traditionally had people out in the field making sort of generic recommendations as to how much they should buy in terms of the inputs they use on their fields. Over the last decade, as Richard tells it, he's been looking for technology that would modernize their operation, actually be useful for sort of defining how much fertilizer they should sell and where people should spend time on fields. The way Richard, for example, uses Mavericks is to get an on-demand update as to how his customers' fields are doing, and then pinpoint where to use fertilizer and different inputs like lime, phosphorus, and nitrogen, and just become that much more efficient as a business advisor to the grower. And really what this is about for Mavericks, and many of our customers use imagery for fertilizer, for making seed recommendations, for forecasting yields. What this is about for Mavericks is really defining of our mission, which is to accelerate the adoption of sustainable agriculture. So we feel that imaging and really the contextual understanding of data around a field is what is the important first step to drive sustainable practices around major row crop agriculture. I should stop there and I'll pass it on to the panel.
And just before we go to Katya, I mean, the key thing is that the AI, the technology is processing that imagery and pumping that data directly to the farmers so they can use it, right?
That's right. So we're looking at satellite data across millions of acres across the U.S., really, in practical terms, doing anomaly detection, and then defining down to a square meter what's happening, and then being predictive of what could happen with different types of inputs being applied in the field.
And the way that farmer accesses that is through an app or something? How do they access that information?
Yeah, so really the output of a lot of our work are programs that go directly into the equipment and essentially automate the equipment. You know, John Deere tractors, for example, are far more sophisticated than really the data is today. Our job is to build a program that's almost like a 3D printer printing the field. So,
amazing, great. Okay.
Thank you, Ravi and Max.
I'll do this.
It's really great to be back to this building. Actually, I'm a University of Toronto graduate, so it's always nice to be back. Also, wanted to mention our company is a CDL graduate, and if not CDL, our company would not be where we are at today. So, great thank you to AGA and all the CDL fellows. My name is Katya Kudashkina. I'm a founder and a CEO of Ujong. I believe in sustainable agriculture and creating sustainable agriculture, so along the same way with Max. And today we have to make different data-driven decisions if we want to have the food that the same food or better food that what we have tomorrow. Our goal is to double average net income for farming operations through optimizing the farm, thus making the farm sustainable and the environment around it sustainable. Our first product focuses on water management. So what we do, we take inputs such as soil data, soil characteristics, agrobotanical data of the crop, irrigation pattern of the farm, and weather data, and then we combine it through our algorithms, and then we provide the output as a recommendation to the grower of when they need to irrigate, on which day, and for how long. Sometimes people forget that a successful implementation of the software system requires not only fancy algorithms, but actually deep understanding on how to integrate the data collection and the output back into farmers' workflow and into the growers' workflow. So I grew up on a farm, and I completed computer science, and I spent half of my time with my team as my data scientists and developers in the office, and then another half of my time in this booth, literally in the field, on the ground, working with farmers, with growers and crop consultants, collecting the data, with soil and the trees. Our preliminary results are quite promising today. So with a very high ROI for a grower, so much that actually one of the growers who runs our pilot sites decided to become one of our largest investors. So I'll stop here and pass it to Lee. Thank you.
Awesome. Thank you.
Fantastic, Lee. Let me just move you on while you crack on. Oh, you got multiple slides. Okay, maybe.
So I'm Lee Redden, co-founder and CTO of Blue River Technology. We built these large agricultural robots. Here's a lettuce bot out in the field. It has these individual modules. And on those modules, they have a camera, they have an actuator, and they have a second camera. So we use machine intelligence to go through and capture the first image, detect individual plants, every individual plant, pull out certain parameters. We turn that into structured data. We then run through an optimization algorithm where we decide how to act on these crops. We then act on the crops in real time, and so from the front of that module to the mid of the module, it's made all the decisions about how to optimize the field. We have a second camera that goes through and makes sure that it's doing a good job with its action. And so it's going through and solving a bunch of problems, and that allows us to get to centimeter level accuracy on a machine deployed out in the field. Currently these run and they work on about 10% of the lettuce in the United States. So who's had lettuce this week? Okay, so 10% chance of any of the lettuce that you've had has been thinned by a machine like this. And so we're using the machine intelligence, basically go through and process. We also use it on our operations side. And so with the big deployment of machines to go through and figure out, and they're complicated machines, figure out which ones are broken. Normally operations like this, when you want to apply a chemical in ag, so with a big boom sprayer, maybe you get 10 square meter resolution if you're using smart technology. This one goes down, and it has centimeter level precision. And so what really enables is for different chemistries that you couldn't normally apply in a selective case, for you to apply those on a plant-by-plant basis. And so that's really the base unit of what you're growing is a single plant, and these sorts of machines allow that. And you can potentially reduce chemical use by 10x or 100x by adding in that precision. Thank you.
Cool. So just so I'm clear, the precision farming means that as it's going through, it identifies which lettuce is a bit dodgy, it needs to be pulled out, which one can be improved upon. I mean, how does it actually work? What is the information that those cameras and actuators are processing? Yeah,
so the front camera pulls out every individual plant in the field, and they overplant just because you put a seed in the ground doesn't mean it's going to germinate. So you have about a 70% chance that seed's going to turn into a head of lettuce, 30% chance that nothing's going to come out. And so they overplant in this certain application at about 2 inches, and then we go through and we see what did really come out of the field, and we choose which plants to keep and which ones to kill. And at the same time, a bunch of weeds that you didn't plant in the field come out, and they're going to take over your crop, and we kill those weeds. And so how does that improve what humans do? Because humans traditionally, I guess you'd have lots of manual laborers going through and manually with hose looking through all these lettuce plots, right? Is that what this is replacing and more efficient? Yes. You basically had two options before. You could overplant and do a thinning operation with manual labor, or you could plant to stand. And planting to stand would be you plant at the spacing that you want, 10-inch spacing, and you see what comes up. And with that, you have about a 30% decrease in yields. If you send humans out to the field, humans aren't perfect in their operation, and what we found with these machines is you get about a 10% increase in yield by running it through the field. And as a data scientist, it is awesome to have this structured data come in that you can then go through and you can tweak the nuances in between spacing of the plants, health conditions of the plants, to optimize the number of plants that you leave in the field, how healthy they are, where they're located with respect to their neighbors, and the size of them, their growth stage. And you're only, in the field, you only get what came out. And that's just nature. I've never seen a data scientist so excited about lettuce. That's great. Finally, Diane, can you give us a sense of what Trait Genomics is up to?
Sure, thank you. All right, so hopefully by now, from some of the other folks on the panel, you've gotten a little understanding of how hard farming is. And really, farming is hard work, and every day we talk to farmers who get up at 6 a.m. or earlier in the morning and get out in the field and come back after sunset. And they're some of the hardest working people, that I've ever met. So for, crop farming really is just as much about growing plants as it is about growing soil. Because soil really serves as the womb of agriculture, and there's this little time lapse of a little plant growing out of the soil to give you that appreciation for how important it is. You put a seed into a soil, and if it's filled with pathogens, you're going to get disease in that plant. And that's going to lower your overall yield or even wipe out your yield for that season. And so what's worse is that a lot of soil-borne diseases actually aren't apparent until the end of season. Plants don't scream and cry and ask to go to the doctor. You don't see it until they're dying. And so often, end-of-season diseases can completely wipe out the yields for a farmer, and that's after they put in an entire season of labor and hard work. And in fact, agricultural diseases, based on some estimates, cost our world economy about an estimated $200 billion of losses every year. And so soil health, it doesn't just end with pathogens. When we think about the soil, actually there are many billions of organisms in each tablespoon of soil. And many of these are actually beneficial and many just kind of exist. It's a huge ecosystem and in fact one of the most diverse ecosystems in our environment. And some of these organisms promote growth of the plants, some provide nutrients for the plant to be able to absorb through the roots. And collectively, these organisms are what we call the microbiome. So you can call it the soil microbiome. Some of you may have heard of the gut microbiome, which is the organisms that live in our gut or regulate our digestion. So in the last decade, the agricultural industry has really started to appreciate the importance of these organisms. Before we were optimizing a lot of genetics of the plants. Now we understand that actually the soil plays a huge role. And so the agricultural biological industry is actually projected to grow to about $10 billion by 2020. And a lot of farmers around the world are using and adopting cover cropping techniques that are meant to enrich soil health. And so we use the genetic fingerprint of the soil to try to predict sustainability, disease, yield, quality, all of these factors that matter to the farmer. And it's actually a really interesting data problem because diseases are not just influenced by the microbes that live in the soil, they're actually also influenced by environmental factors, soil moisture, soil texture, weather, all sorts of different data. And so it's a really rich data problem. Building a holistic model to capture all these interactions, many of which are nonlinear, is really necessary and requires not just interesting and complex machine learning approaches, but also very thoughtfully curated metadata to be associated with each of these data points. And so, next slide. At Trace Genomics, we're solving this problem by launching the first scalable microbiome test for the food supply. And so this kit allows farmers to easily order one and get an easy and affordable way to assess their soil for diseases, for soil health indices, and evaluate their many farming techniques that they're currently adopting. And so when we receive our sample in our lab, we use genomic sequencing, to fingerprint the soil, essentially, and that generates many, many hundreds of millions of sequences, and that represents all the organisms that live in the soil, so pathogens, beneficials, pests, and so forth. And from that signature, we build a predictive model for yield and disease. And so we use machine learning techniques then, in this case, to reduce a lot of the high dimensional features in our data set. So going from many millions of sequences to hundreds of thousands of organisms to try to predict yield and build models that generalize across fields and across variables. And we bring in biological knowledge from years of experience in microbiome science to interpret and validate those models. And then we focus a lot on curating the metadata that's necessary to be used as predictive features or predictive labels to train our models. So our vision is really to build the first agronomically relevant microbiome database as one of the new waves of startups that are now kind of emerging in this new time of, during the market for intelligence. We are really bringing our experience in machine learning and biology together to try to solve it the right way from day one. So in the sense of, kind of what Steve was alluding to before with his talk, not just building a big data database, but rather building a predictive data database, thinking from day one about how to collect that data and how to train those models and how to lower the variation and optimize, predictive value per byte of data. And then I guess last point is kind of just recalling something that Jay said in the beginning of this day in his intro, that as the cost of prediction falls, the value for human judgment increases. And that really resonates with me because it really encapsulates our approach to machine learning in the wild. Right? We're not telling farmers how to farm. We're not telling them how to do their jobs. We're just figuring out what the machine can do better, and we make that solution scalable. And we deliver that to the farmers to help provide insights so that they can make better decisions about how to farm, how to prevent disease, and how to really get their value back for all of their hard work.
Amazing. Well, we don't have that much time for questions, but Diane, Lee, were you going to jump in there?
Yeah, I was going to say, so the last panel was asked what they saw would happen in 5 to 12 years. And I was at a breeding conference a couple years ago, and they were so excited about like the big predictions or about what was going to happen with soil and what was going to happen with plant roots. And at the conference, so breeding accounts for about 2% increase in yields over 60 years, and just had a huge effect on pretty much every single crop that you eat. And you just compound that out. And they were so excited about, for the longest time, you saw what was coming up top, and you optimized for that. And what they were moving into next was roots and soil. And so this builds on where that exponential curve is going and what the researchers were predicting.
One of the things I wanted to ask about was just the interaction with farmers. So we hear about Max and kind of the nature of the data that goes straight to the machines. But Diane, in your case, one of the issues is that they don't want an app. They want kind of much more simple ways of getting that information to them. Because I can understand you need to process all this stuff and you can use machine learning, but how do you actually give it to a farmer so they can understand and actually utilize it?
Yeah, so we put a lot of focus on the design and the user interface and usability of our reports and our insights, really kind of taking a very powerful technology like genomic sequencing and machine learning in this very data-heavy problem, and then encapsulating that in a super easy-to-interpret one-page report. That's really, I think, super important when it comes to delivering AI in the real world, is understanding the user and putting it first.
And in your case, it's a PDF, right?
Yeah, so we actually email reports. It's
Yeah.
low tech, but it's what they use and what they pull up on a daily basis.
So if I can just jump in, we do deliver stuff to equipment, but one of the challenges, as I'm sure everyone on this panel knows, is that growers are really, many of them are business people, and they manage land, but they have a lot of advisors. And in fact, it's those advisors that make a lot of the decisions. They might look at your report, for example. They're the ones that review our programs before they go into equipment. Those are the crop advisors, the agronomists. And I think one thing we've been finding is you can build the best. There are even silver bullets to build, but no one will actually put them in the weapon until you put them in the right hands. And I think in our industry we found I think I'm sort of seeing this happen across agriculture tech right now. The retailer, the agronomist, the distribution channel actually is a fantastic way of reaching farmers. Farmers are not necessarily they're your ultimate customer, but ultimately the people who are going to distribute and use the technology are the service providers. And I think this is kind of an exciting moment in agriculture for all of us, because we've all been sort of building this incrementally. None of the pipes were in place. The data wasn't even there in an organized way to work with on a large scale. And I think some of those pieces really in the last year have been coming together. I just came from a conference last week where that was sort of the theme, was finally, 10 years ago, there was an article in The Economist that I read all about Monsanto and some of the things they were doing in precision agriculture. I think we're actually about a year away from some really huge leaps happening that enable a lot of the AI that we're talking about.
On which note, you've got about 2 minutes left collectively. I'm going to ask each of you in about 30 seconds to give us a sense of, in the next 5 years, where do you see your businesses going, and what do you see the next really big challenge that you're aspiring to solve? Start with Max.
So, when we think about how to really advance sustainable agriculture, there are many tools, but the problem is how do you get them into people's hands and how do you drive behavior? I think at Mavericks we're really trying to collect the right kind of data to be both predictive about a field's performance and a field's risk, and ultimately drive the economics, the right and good economic decision-making around a farm. Because that, for us, we think really drives sustainability. So for us, it's about finance and risk, and I think you're going to see a lot of agriculture move in that direction in the next few years.
Katya.
I think there will be a lot of conversions. So right now you see image analysis, data-driven company that moves the hardware company, and so on. And I think that you'll start seeing a lot of conversion in the next 5 years. But we also right now are dealing with very different crops, and that's another part of conversions too.
Lee.
I see plant-by-plant care. So instead of managing your field on a giant level where you think about, something as an acre worth of corn or an acre worth of cotton, that you go through and you have machines that can go through and take actions on these individual plants. And they're reactive to what's going on in the field. And they're, when my grandma had a farm, when she grew up, it was 64 acres. And they did hand harvest for most of this. And it was a person actually in that field. And that's how, I can see machines going through and getting that detail and giving that back.
I see it following a lot of the trends in healthcare, actually. So in terms of companion diagnostics and really being able to tailor specific treatments and optimize specific formulas for each farmer using a combination of their genetic information, their water, their sensor information, and operations, and really building that whole package.
Brilliant. I'm going to throw in one extra one from a company that I interviewed from Japan called Spread. And they're all about using hydroponic farming and automated farming and AI to create lettuce with very little water. And not only are they thinking about producing lettuce in a desert, but actually harkening back to what Chris Hadfield said when we're colonizing space, they can grow stuff on Mars. So on that note, with 12 seconds left, I'm going to say join me in thanking this great panel and on to the next one. Thanks, guys.